Good morning and welcome to Calculus in the AM. I'm your host, Mr. Shindaka, and today's episode is brought to you by Quartet brand adult diapers. The brand you need when you're in need. Quartet adult diapers. And you guys laugh, they're not just for senior citizens. If you were ever gambling or anything like this, you got a lucky machine, you don't want to leave that machine. As soon as I walk away, somebody's gonna scoop in. You know, you're supposed to lean a chair against this stuff. That's for losers. I stay there until I cash out. Quartet brand only. They aren't just a diaper. They feel like home. Back to this. So you can imagine this kind of floating in front. The things I have to do to make money. Right? Reduce that exponent by 1, and there you got it, right? What do you think of this? Well, let's think this then, yeah. And that's why I was... Hey, yeah. So 6x squared, I was going to use... Actually, I was going to use that exact same setup here. And then put a 6 in front. How does this work compared to what we did before? You guys see, it's really, I think of it as 6 times the x squared, right? Well, if it was just x squared, I'd say, well, 2 times x to the power of 1 is the derivative, right? I was 6 times that, right? 6 times 2 is 12, x to the 1. You guys get that? Playing around. I know Hashim does. So, can you sort of see a pattern? Reduce the exponent, pull the old, I think of it first, pull the old exponent in front, then reduce the exponent by 1. It's written right here. So, and no, in words, well, you can, yeah. But if the function is x squared, x to the n, put the n, the old exponent, in front as the multiplier, and then x to the, reduce that exponent by 1. Does that make sense? As long as the n here represents an actual number. Okay? You couldn't have x to the x. And there's a function possible like that, right? Or you can't have, to do this, you can't have something like x to the natural log of x. We've got other things, or x to the sine of x. Other things going on. So, now knowing this, find the derivative, and I've got a new notation. But first of all, before we do, review. The definition of the derivative refers to that formula. If I say use the definition of the derivative to find, and that's what the quiz will say, you use the limit of h approaching 0 for f of x plus h minus f of x all over h, that limit. Work it out long. If I don't say that though, no, hang on to your thought, I'm sure you're correct. If I don't say that, use the shortcut that you just found, right? Question?
Because there's 2 different definitions using at h. What's the other one?
The other one's at a particular point. Use the definition at a point, I think it's called. I will stipulate too, and I actually say, find the slope of the tangent line to the figure, using the process from 4.3, and I'll give you a numerical point. So on the open book quiz, it'll be clear. If not, clarify with me. Now, the description of the derivative is what I really want you to memorize. Because from now on, don't use the definition from this section on, unless specifically asked to. Okay? Promise you that. But what's a description of the derivative? The derivative is just a formula that gives you the slope of a tangent line to a particular point on the function. Now, I could phrase it a little as and ands differently and stuff. But I need you to memorize that and internalize it. What is the derivative? It's just a function, even. We'll say, yeah, it's an equation, and sometimes you're right, though. Sometimes it's, sorry. So the derivative, everybody, not just one person. The derivative is just a, we'll use the word function. Function. Parlez plus fort. More of you, Mac. Come on, you're smiling, and you're all smiles and more. You guys. The derivative is just a function that gives you the slope of the tangent line at a particular point that you want. Yeah. Okay, now, you'll have that function. It might be the derivative is 2x. That means anywhere you want the slope of the tangent line. If x equals -3, put that into 2x, -6. If x equals positive 2, put that into 2x, you got a slope of 4. It's an equation or a function. Now, let's find all these derivatives. The first one, we'll use a notation we've already seen. Since it's called f of x, I'm going to call it f prime of x. That means the derivatives. And looking at this, using our new pattern, what do you do with the exponent? Bring it down. Downtown brown. It's your rule. So what is this one here? 10x to the 4 becomes 40x. 4 times 10. And the exponent becomes x to the 3. Good one. Now, I want to show you a different notation. And it's a variation of, you know how slope, because remember derivatives are slopes of tangent lines. You ever see slope as, and don't write this down, but slope is equal to the change in y over the change in x? Yes or no? Have you guys seen that? Okay, physics. That means the y minus y over x minus x. Do you know what Greek letter this triangle is? Delta. Delta x, delta. Okay. That's a capital D, delta. The small d is like this. It looks sort of like a musical note. You see that in chemistry sometimes. Partial charges. What we want, though, is we're going to use, if it's given as y, I could use y prime, or I could, and you'll see this notation quite often, dy by dx. This is nothing different from f prime of x. It's just another type of notation. Okay? It's like, you know how you can write a division problem? Same problem. 48 divided by 6. All three of those are equivalent expressions, agreed? dy by dx is the same operation going on as f prime of x. Okay, that's all I'm trying. So you're not learning anything new other than a new way to write. Now we got a negative though. So you still do the same thing. -3 is the number in front, but you multiply by the old exponent. Negative and negative is a positive, right? Bad thing happens to a bad guy, that's good, so positive. 21, right? X to the? -8. That's -8. Okay. Now C, before I do the derivative, I want to write this in a little different way. 11 divided by x. If you pulled that x to the top, what would it become? -1, agreed, right? When you flip the exponent up, reciprocal-wise. This makes it easier to think about doing the calculus. Now, I repeat, I do not now say equals the derivative. It's a separate thing. So separate, I'll actually change colors. Now, this time I'm going to call it y prime, just so you're used to seeing this. It's not a big stretch from the f prime of x notation, right? Y prime is the derivative formula. I tend to use dy by dx the most, actually. It's probably, I like it the best. And when you learn more calculus, it comes in handy. So this derivative, before I do any calculus, x to the -1 is what I flip. And if you see anything over, like over x squared, you get x to the -2. It'll be way easier. So anyways, -11, right? X to the -2 is the derivative. Lastly, what was the root? So before I do any calculus, I'm going to recall square root, power of half. It's like a compromise. You take half. But I'm all right. You're half wrong. Something. The derivative in this case is 1/2 times 4, 2. X to the, subtracting 1/2, 1/2 minus, subtracting 1/2, from half, subtracting 1. negative 1/2, because you're minus 2 out of 2. Now the arithmetic ain't too crazy, but we got to be aware of these
Is
things.
it okay to leave it there on top?
That's what I was
If
just
you
going
want
to talk
to
about.
put it-
Sometimes, I'll accept these, but you got to understand, what does this mean? Negative exponents means you can take the reciprocal, put it under downtown, right? Downtown Brown. So this is the same expression. I want you can leave it like this unless I state otherwise, no negative or fraction exponents. I sometimes say that. So there's two things going on here. That becomes 2 with the x downtown, x half on the bottom, denominator. And then the half itself means square root. So if you were to evaluate this, like if you were to try to find this value at 9, you put it in there. I actually think people would have an easier time evaluating given this expression form than this one. So that's another reason why you want to know what the heck does that mean. It means put it down there and go for it. Makes some sense? Okay, you guys too? No? Yeah, maybe. Now, right, we got it till 50. Right, okay, so we've got time. Your face piles of trials and smiles. It rouse to believe that you perceive through the webs they weave. Well, let's take a look at these. I was just giving things with one term at a time. What about this? Addition or subtraction? You just do them one at a time. Think of this first thing, then the second thing, then the third thing. Let's go through these, because you'll need the practice. So A, I'm going to use the dy by dx notation only because I want you to be familiar with it. Then you do the derivative of the first chunk, 8 times 9. Can I get you guys to do those 3 things basically, and then we'll see something right off the bat. I'll give you a start off with B. Before you do anything, rewrite it without doing a derivative. Something like 3x to the minus 1. Subtract and keep going with that. First do this then. Check them off. Pause the old video, and you can check your answers after. Okay, I got some answers worked out with you guys. Let's just take a look one term at a time. First one. Agreed? 72x to the negative 7? Okay. Agreed? Did anybody have 5 times 4, 20, to the 3? Yeah, something like some variation of that? Why not? This is a plain old number though. Yeah, I didn't focus on it too much. If you have a number, I don't care what it is, a constant, no derivative. And think of it this way. If you wanted to attach an x to it, you could say that's x to the 0, right? Take the 0 down. 0 times 7 is 0. I don't care what's behind it. It's 0. Does that make sense? If you want to think of the rule way of doing it. Now, I don't even need the plus 0 again. So I can just get rid of that rubbish. Or I can put it back. Bang. Anyways, first one's good, eh? Now I said before you even try calculus, rewrite this expression. Get rid of the denominators by flipping them up and having negative exponents, okay? Are we all good with that before we even think of calculus? Now the rule's pretty easy to apply, right? Negative 1 times 3. Okay. Did I get these right? Double check me. I do, like I'll make a stupid error, 2 times 8 is 75 or something like that sometimes. Not on purpose either. It's a little ridiculous, but I do make errors. Okay? Oh, my nose is really sneezing. C. I gave you a hint. We don't have a rule for this exponent dealing. I got hiccups. So multiply it out, get 3 terms. Trinomial? I think I got it right. 50x minus 30 is the derivative then, okay? The only person who would know how to deal with that without doing that is Hashim. Have you forgotten?
No, I think so.
Good.
Isn't it a chain rule? Yeah.
I'm going to rewrite this, but I want it to stop and rewrite it with you. That root is over the whole thing. I'm going to think of this as the fraction under the square root, root 3. 1 over root 3. Does that make sense? Now, I'm going to write it one way and then write it another. This is not calculus yet. I'm just rewriting algebraically. So square root of 1 over 3. Now, I'm not going to keep it this way because what's the square root of 1? It's 1. So I'm actually going to write it as just 1 over root 3. I don't care which way you write it, though. I want to show it in both ways. So number, I have, and then I pulled the root x. Would you guys agree, and I'm going to erase this in a second. So. Is this the same expression? Yes. So I've got this, but instead of root x, it's easier to do calculus with an exponent, so x to the half. So I think of it as there's a fraction in front, x to the half. Minus 2. The 2 I'm going to keep as a 2. But the root x on the bottom, half, but make it negative to rip it up top. Plus 6. Zippity-doo-dah. There we are. Now what? I'm ready to do a derivative. I don't care what that is, I'll just leave it. 1/2 times root 3, 1 over root 3 is 1 over 2 root 3. The exponent is negative 1/2. Two negatives, it's positive. X to the minus 3/2. 0 for the 6, right? I'm going to leave it like this. We know if we need to flip it around, we can. But unless otherwise instructed, you can leave halves and negatives in your answers. Boy, I just feel like I'm on the verge of a volcanic sneeze. But whatever. But if you do have to sneeze, I recommend this product placement. Co-op brand tissue. It's gold. Co-op gold tissues. The name you can trust. It's good stuff. Save it for later. Making a collage, some artwork. That's going to be gross. I was going to say it's sticky. It's a great problem here. Find this, where the slope of the tangent line is 6. We have a function, but what we need is a formula that gives us the slope of the tangent line at any point. What do you call that? The derivative is a function. Will give us a function that is a formula that finds the slope of the tangent. The derivative is just a formula, a function, an equation. We do the derivative, and this is a slope-making machine, right? 3x squared. 3 times 2 is 6x. Minus 3. Hey, not only that, it's a function I can live with. It's a quadratic. I love quadratics. I live for quadratics. I do. Now, I'm just doing this because I'm a math person. It's my first instinct. And you know what? I'm going to do this. I'm going to factor. No, I'm not. Don't. And I'm stopping myself now. I'm solving a different problem. Despite all your itchings to factor this puppy, which does factor out a 3 easy, right? I see that right away. But hey, hang on. Hold the presses. I want to find when the slope is 6. What does this represent here? This is the notation that's sort of like the f prime means the slope at some given x value. We want to find that x value, don't we want to? The coordinates at the 2 points, well, find the x coordinate first. X part of the coordinate, and then the y. So the slope is 6. Guess what? I'm going to put 6 here. And there's the formula on the right-hand side that gives me the slope of the tangent line, right? At any given point. Now we've got to solve for the x. Now I put it over, make a 0, and then see if I can factor up this side of the gun. Minus minus, so minus 9. I hope we can factor this. Well, hope. 3 comes out of everything. Reduce if you see a common factor. Very first thing. I'm going kind of fast because I'm expecting that you guys know how to factor. So minus 3 must have came from plus 3 times x minus 1, because that adds up to the center term. Now I have 2 x values, right? That will give me a slope of 6 from that slope machine we call the derivative, right? So I'm going to give those 2 little solutions here. X equals -3, or the other solution, x equals 1. It said 2 points, though. Now, if I graph this cubic equation here, no, there's not going to be that many humps. But anyways, there's 6 somewhere here, Billy. Here and here, something like that, right? We found those 2 x coordinates. We need to find the matching y to find points. And it's y from this. So I need to find f of -3 and f of 1. So I'm going to just kind of put this, and I know it's crappy work. I should be working straight down. But the y coordinates. So the y coordinate, that corresponds to 3. So f of -3. -3 cubed is -27. -3 squared is 9. So plus 27. This is way easier than I thought. Minus minus, so plus 9. So I get -3 common 9 is 1. And I'll put that down at the bottom here. -3 common 9. Or the other answer? Well, it's going to be 1. Well, we'll figure out the rest of this. What's f of 1? The y coordinate, when x equals 1. 1 plus 3 minus 3. 1 comma 1. This answers my problem. Okay? So if you stop short of here, I'll give you 4 or 5 or something like that, right? If I specifically asked for points. If I didn't ask for points, you'd stop there. Now, I'm going to pause the video and ask you guys